microcontroller unit pin randomly change the state from 1 to 0 or 0 to 1 even when your code is perfectly working fine? This is not a bug. It's not a bug. It's a problem of missing pull-up register. Welcome back to the channel. Today we are breaking down pull-up registers, not the textbook definition, but practical tips and tricks where every embedded engineer should know. So here in this session you will learn why floating inputs cause unpredictable behavior and when internal pull-ups are not enough and the common mistakes that lead to noisy signals and hard to debug failures, right? So I'm going to give you a very simple tip to remember this confusion. Okay, so it's easy for you to crack the interview. Let's get started. So I hope you are all aware of what is pull-up register, pull-down register, or open drain, or high impedance, okay, or floating input. All these come, with GPIO pins, input-output pins. Maybe it can be in input mode or it can be in output mode, right? So I'm not going to get into the basics of pull-up registers or pull-down registers and other things, but I'm just going to give you a small tip over here which will help you to remember and crack the interview in an easy way, because I know this one topic where when to use a pull-up register, when to use a pull-down register, if it is open drain, or during open drain do we still require pull-up register, or how it works with a mechanical switch, or how it works with a longer cable. All those things I'm going to draw a simple flow diagram, and based on that you will be able to simply remember and revise this concept in just 2 minutes. So without wasting further time, let's get started. So the question which might arise here is, the first question which will arise is the pin, and it can be a GPIO pin over here. I'm just going to consider microcontroller GPIO pin, simple. Okay, is the pin ever undriven or of high impedance? So this question you should come to into your mind, and everything is in datasheet, but still I'm giving you a heads up so that it's easy for you to crack. Even if you are reading a datasheet, it's easy to get to the flow and what is required, how to read the datasheet. All those things will help you here. So the first is the pin ever undriven or high impedance? Then over here we have two options, no, and let me take in another color pen. If it says no, and if it says yes, okay. If it's a no, then we don't require pull-up register. Simple, okay. But if it is of high impedance pin, or if it is floating pin, then we do require. Then again the question arises here, is the pin, the next question is like, is the pin open drain or wired one, or wired or, I would say, the better option. Again here we get two options, the one with yes and the other one is no, right? So if the pin is open drain, then we require a pull-up register, and it is a must use pull-up register, correct? Now if it is a no, then the next question which you should ask is like, is there a mechanical switch used? Mechanical switch used. Again there will be two options over here, one is yes, one is no. So if it is yes, what we are going to do, and if it is no, what we are going to do. I'm going to explain it to you, give me a second. So if it is a yes, then again we have two conditions over here. If the switch is shorted to ground, that's the question. And if it is yes, then we require a pull-up register. Simple. And the second question which arises is the switch shorted to VCC? Then we require pull-down register. So the question arises here is, are we using a long length cable, or is the environment, is the environment noisy. Then again we get the two options over conditions, right? So if it is yes, and if it is no, what happens? So if it is yes, then definitely we require a strong external pull-up resistors. And if it is a no, then we can work with the internal pull-up resistors. We don't need to worry. We already have in GPIOs, usually nowadays the microcontrollers, they have internal pull-up resistors, so that shouldn't be a problem. Okay. Now let's discuss about some few pointers which will help you to remember things here. So some of the engineering rules which I feel is very important. Okay. Now in the tree which I have mentioned, it's a very simple but yes, a very smart way to remember the things. From the tree only I am just going to deduce few pointers over here. Is like ground is quieter than VCC. Ground is quieter than VCC. Hence, we can say pull-up resistors are preferred. Pull-up resistors are preferred. So if the question they ask, simple question they might ask you, is pull-up resistor preferred, or if they can ask you like, why is pull-up resistor preferred over pull-down resistor? Then you can say ground is quieter than VCC, hence pull-up resistors are preferred. So this one you can say. Then the next comes is CMOS defaults to high easily. That is also a plus point for preferring a pull-up resistors. Okay, so that was also then open drain logic fundamentally requires pull-up resistors. So hence pull-up resistors are preferred. This also is there. Now coming to the long wires or long cables. Okay, here the capacitance increases with the increase in the length or the distance, right? So pull-up resistors are better. Okay, cool. Now few of the pointers also I want to mention here is for reset pin, it's pull-up resistors only. Usually it is pull-up resistors only. I think very less I have seen where they have used pull-down resistors, but mostly it is pull-up resistor only. Okay. And now this is one of the questions they might ask you. Follow-up question is like, what if pull-down and pull-up resistors are both enabled? So you can say both cannot be enabled at the same time, but in case accidentally if both are enabled or joined together, which are those pull-up and pull-down, then voltage divider circuit is formed. Voltage divider circuit is formed. So these might be the two follow-up questions they might ask you based on the flow diagram which I have shared with you. As you can see on the screen, I have attached the flow diagram over here for pull-up and pull-down resistors, when to use, when to not to use, and what conditions they come up with. Based on that, what type of pull-up resistors or pull-down resistors you need to use or you need to consider when you are considering a GPIO pin, it can be like, usually the external one is used with I2C. So all these where they have been used and all those things, it is a very important part over here. So hence please make sure that you by heart this flow diagram. It is very easy, you don't need to even mug up. Once you understand the flow, it is very easy to understand. Okay, so if this was useful for you to understand pull-up resistor beyond the textbook, please hit the like and subscribe for more practical embedded tips. Also drop your questions in the comment box, and I will see you in the next